This tutorial is going to walk through this pedigree analysis problem. If you haven't looked it over recently, take a minute now to pause the video and read the problem, then come back to see how we're going to approach it. This is a pedigree problem. In order to answer these kinds of problems, it's important to know what all of the symbols mean. If you're not yet familiar with reading and interpreting pedigrees, you may want to check out the pedigree tutorial from last class, then come back to this one, which is a bit more advanced. A good way to approach pedigree problems is to start by figuring out how the trait is inherited, if you're not told so in the question. In this pedigree, we have an affected daughter coming from two unaffected parents. This tells us, first of all, that the trait must be recessive, and second, that it must be autosomal, not sex-linked. For dominant traits, affected children must have at least one affected parent. This isn't the case here, so it must be recessive. For X-linked recessive traits, affected females must have affected fathers. This is because chromosomal males only have one X chromosome, so their phenotype will be determined by whatever allele they have on that X, which they then must pass on to their female offspring. In order to be affected, an XX child would have to inherit an affected X chromosome from each parent, meaning that the father would have to possess an affected X chromosome, and thus be affected himself. Now that we've figured out the mode of inheritance, we can designate symbols and start to label the genotypes of different individuals on the pedigree. Let's let capital A indicate unaffected, and lowercase a affected. First, any affected individual must be homozygous recessive, little a. Then this individual here, who has an affected parent but is not himself affected, must be heterozygous. Back to the top of the pedigree, two unaffected parents who have an affected child must also be heterozygous. And since we're told to assume that anyone coming into the family is homozygous unaffected, we know that these individuals are both big A. So now let's see who the question is asking about, and whose genotype probabilities we'll need to determine. We're trying to calculate the probability that question mark will be affected by this trait. Since this is an autosomal recessive trait, the only way that they can be affected is for both of their parents to be heterozygous. We already know that the father is heterozygous, but what about the mother? We have to start at the top and determine the probability that an affected allele has been passed down through each of the generations from one of the heterozygous great-grandparents. Let's start with the grandmother. She's unaffected, coming from two heterozygous parents. So the probability that she is heterozygous is 2/3, and the probability that she's homozygous unaffected is 1/3. Only if she's heterozygous can the little a allele get passed on any further, so all subsequent probabilities will depend on that being true, and our final calculation will account for all of these probabilities. So if she is heterozygous, the probability that her daughter is heterozygous will be 1/2. And if she's heterozygous, the probability that her daughter is heterozygous will be 1/2. If all of these things are true, then the probability that these two heterozygous individuals will have an affected child is 1/4. Now we have the probabilities and genotypes for all of the relevant people figured out, and we can solve this problem. The probability that question mark is affected will be calculated using the product rule, accounting for everything that must be true in order for them to be homozygous recessive. So we have the probability that the father is heterozygous, times the probability that the mother is heterozygous, times the probability that two heterozygotes will have an affected offspring. We know that the father must be heterozygous because his father was affected, so the probability there is 1. The probability that the mother is heterozygous is the probability that the grandmother inherited the little a from one of her parents, times the probability that, if she inherited a little a, she passed it on, times the probability that her daughter passed it on as well. And the probability that, if the parents are heterozygous, question mark will be little a homozygous is 1/4. So our final probability that question mark will be affected is the product of all these separate probabilities, or 1/24. And we're done.